In 1979, a spacecraft sent back an image that nobody expected to see, a plume of material rising 300 kilometers above the surface of a moon. Not a moon with a thick atmosphere, not a moon near the warmth of the sun, a small, yellowish moon at the outer edge of the solar system, 628 million kilometers from Earth, and something on its surface was erupting. When we first mapped the outer solar system, we expected what we always expect from moons. Cold, dead, cratered. The same story we had told ourselves about every rock orbiting every planet. We had seen our moon. We had seen Phobos. We had seen Callisto. Moons we knew were ancient relics, frozen records of the early solar system, beautiful in their silence. Geological museums suspended in orbit, unchanged for billions of years. We looked at Io and saw something small and yellowish and distant. We gave it a name from mythology. We filed it away. We were profoundly wrong. Io is not silent. It has never been silent. It is the most volcanically active body in the entire solar system, more active than Earth, more active than any planet we have ever observed. It has over 400 active volcanic regions. It resurfaces itself completely every few thousand years, burying its own history under fresh lava. But the volcanoes are not even the most terrifying thing about it. Welcome to the moon that Jupiter is slowly destroying. Io's volcanic eruptions are not like the ones you have seen on Earth. The lava that pours from its vents reaches temperatures above 1,600 degrees Celsius, hotter than any lava on our planet, hotter than some stars are at their surface. Its eruption plumes climb 300 kilometers into space, higher than the International Space Station orbits Earth. There are active lava lakes larger than entire cities, glowing red through Io's perpetual sulfur haze. The surface is bright yellow and orange and white, the colors of sulfur dioxide frost, painted fresh over older sulfur, painted over older lava, endlessly. There are no impact craters visible on Io. Not because it hasn't been hit, everything in the solar system gets hit, but because every crater is buried almost immediately. The surface you are looking at did not exist a few thousand years ago. The surface underneath that one didn't exist a few thousand years before that. Io is not a geological record. It is a geological furnace that incinerates its own records as it goes. But here is where the real question begins. Io is 628 million kilometers from the sun. At that distance, there is almost no solar warmth. The other moons of Jupiter are frozen, Europa beneath its ice, Ganymede locked and ancient, Callisto a silent record of impacts stretching back to the birth of the solar system. They are cold because they should be cold. Io should be cold too. Nature has a rule about heat and distance. The further you are from a heat source, the colder you get. It is not a suggestion. It is physics. Io violates it, and the reason is Jupiter. Io orbits Jupiter in exactly 1.77 Earth days. The next moon out, Europa, orbits in 3.55 days. Ganymede orbits in 7.15 days. These numbers are not coincidences. For every one orbit Ganymede completes, Europa completes exactly 2. For every one orbit Europa completes, Io completes exactly 2. The 3 moons are locked in a gravitational resonance. They pull on each other, they tug at each other's paths, and the combined effect forces Io's orbit into a slight ellipse. That ellipse means Io's distance from Jupiter is always changing, a little closer, a little further, a little closer again, every orbit. Jupiter's gravity is immense. As Io moves closer, Jupiter's pull stretches it. As Io moves further, Jupiter's pull relaxes. The moon flexes. The rock inside it bends. The way you bend a metal wire back and forth in your hands until it heats up. Io is being squeezed by Jupiter on every single orbit. The friction of that squeezing generates heat, not at the surface, but deep inside, in the mantle, where it builds until it has no choice but to come out. The volcanoes are not a feature of Io. They are Jupiter's fingerprints. Every eruption you see on Io's surface is Jupiter expressing itself through a moon it will never let go. The largest volcanic feature on Io is called Loki Patera. It is a lava lake, not a small one. Loki Patera is 202 kilometers across. If you placed it over France, it would touch 4 countries. Its surface periodically overturns. The cooling crust on top sinks, fresh lava rises underneath, and the entire lake begins its cycle again. Scientists have been watching it for decades. It runs on a roughly 500-day schedule. It is almost perfectly predictable. It has never stopped. The largest active lava lake on Earth is at Nyiragongo volcano in the Democratic Republic of Congo. It is approximately 250 meters wide. Loki Patera is 800 times larger, and it is one of more than 400 active volcanic features on a moon that is smaller than Earth's moon. On Io, there is no solid ground in the way we understand it. There is a surface, sulfur plains, mountains pushed up by the constant interior pressure. Lava flows kilometers thick. But underneath all of it, the rock is being perpetually recycled, melted, erupted, cooled, buried, melted again. A planet-scale conveyor belt that has been running since the solar system was young. On March 2nd, 1979, a scientist named Stanton Peele published a paper in the journal Science alongside two colleagues. They had done the mathematics on Io's orbital mechanics, the resonance with Europa and Ganymede, the tidal flexing, the heat generation. Their conclusion was direct. Io might be the most intensely heated terrestrial body in the solar system, with extensive volcanic activity as a result. The paper was published on March 2nd. Voyager 1 reached Io on March 5th. When the images came back, a navigation engineer named Linda Morabito was processing them for routine spacecraft positioning. She noticed something at the edge of Io's disk, an unusual brightening, an arc of material rising above the surface. A plume, climbing 300 kilometers into space. The first active extraterrestrial volcano in human history, discovered 3 days after the paper predicting it was published. Voyager 1 continued outward. It would become the furthest human-made object ever launched. But the image it captured of Io, that small erupting moon silhouetted against the dark, changed the question scientists had been asking about the solar system. We had been asking, where is it warm enough for life? Where does the sun's light reach? But Io answered something different. It showed that warmth does not have to come from a star. It can come from gravity, from orbital mechanics, from the invisible forces that moons exert on each other across millions of kilometers of empty space. If Io had heat, it should not have. What else did? There is one more thing about Io. Every eruption removes material from its surface and throws it into space. Jupiter's magnetic field sweeps up much of this material, sulfur dioxide, oxygen, sodium, and forms a glowing ring of charged particles around Jupiter called the Io plasma torus. It traces Io's orbit. It pulses with every eruption. It is Io bleeding into space, orbit after orbit for billions of years. Io is losing itself. Slowly, over geological time, it is being depleted. Its interior is being stirred and cooked and expelled. Jupiter will not stop squeezing it. The resonance with Europa and Ganymede will not break. This is not a temporary situation. This has been happening since the formation of the solar system, and it will continue until Io is exhausted. Jupiter is not neglecting Io, it is consuming it. And yet, here is the thought that stays with you. The same tidal forces squeezing Io are also acting on Europa. But Europa's heat goes somewhere different, not into eruptions, into melting ice. Beneath Europa's frozen crust, scientists believe there is a liquid ocean, kept warm by the same gravitational engine that keeps Io burning. Io is the visible fire. Europa is the hidden water. Two moons, the same mechanism, two completely different worlds. Io burns so that Europa stays liquid. The most violent moon in the solar system may be the reason the most potentially habitable one can exist at all. So when you look at Io, at its sulfur plains and its lava lakes and its plumes rising silently into space, you are not looking at destruction. You are looking at a mechanism, one that has been running for 4.5 billion years, one that neither Io nor Europa had any say in. Jupiter is not just a planet, it is an engine, and Io is what it costs to run.